Okay, so it looks like we're live. Welcome, everyone, and welcome to Joao. And today I'm joined by Joao from Cartesi. We're going to be talking about a lot of really cool stuff. A lot of the things that I would say are being worked on with their team are very unique. And I think it's going to be a great conversation. So, to kind of get things started, do you mind introducing yourself and also your company?
Hi, thank you for having me here. I'm João. I'm a developer advocate for Cartesi. Been working in developer relationships for this last year and a half, I think, and it's been a real nice journey. What Cartesi does is we act mainly as an out VM for Ethereum or EVM-based blockchains, and we differentiate ourselves from everyone else because we provide this very specific execution environment that brings Linux to the blockchain in a very verifiable way, right? And this is quite a leap from everything we have from now, because you can start creating, because of that, your smart contracts in Rust, Python, Go, whatever language you want, actually. Anything that would run on Linux theoretically should run with us.
Very cool. That's a good explanation. I'm going to be asking you a bunch of questions about that.
Yeah, please do.
So can you kind of tell me, I guess, what exactly, if someone just heard that sentence, like what does it actually mean you can run Linux on any environment? Like in practice, does that mean you can essentially spin up a server and install packages and write your own programming language, or kind of what does that typically look like?
So that's a very good question. What we actually did was we brought through a lot of research and a lot of effort, right? This RISC-V machine to life, and we put Linux on it, but we made it deterministic at the same time, okay? So the general idea is that you can run it in many ways. You can run, for example, on top of another blockchain, a layer 1 or a layer 2 as a rollup. So you can spin up various nodes and then have fraud proofs there, so you can verify your computations. And it basically becomes what is an app chain, right? This is our more famous solution, the Cartesi rollups. But right now we are also developing the Cartesi Coprocessor, in which you can use Eigen, for example, and we can host our Cartesi machine there for it to be the execution environment of your application. So yeah, essentially what that means is you're running a deterministic RISC-V emulator, so you can run it basically anywhere since it's an emulator, right? And it does have its particularities in the sense that being deterministic allows us to run specific fraud-proof systems that we develop, like PRT, which is our permissionless referee tournaments algorithm, or Dave, which just came out and it's pretty insane. But we can, I think we can get probably on that later. But yeah, so the whole idea is to bring the motivation behind it. I think it's to bring every technology that we always had and we always created and we developed in decades of Web 2 to the Web 3.
Makes sense. Okay, cool. So we'll dive a little deeper into that. So the two main, I would say, products that we're going to be talking about today are the Cartesi virtual machine / rollups and the coprocessor. So before we get into the coprocessor, let's dive a little bit deeper into the initial product and kind of how developers are utilizing that today and maybe how long it's been around. So yeah, when did you all launch this initial product, the VM, and with the Linux environments?
So the VM was a long effort. It's been created like, I think I've heard about the Cartesi VM for the first time around 2018, if I'm not mistaken. I might be wrong there. But the Cartesi rollups, I think, came to life actually in 2023. So in 2023, we had a less perfect version of it. Now we have so much more convenience that our node is so much more robust that it became a really much better experience for you to develop on Cartesi, right? So through our CLI, you can easily bootstrap a project, start coding on your favorite language, and deploy your Cartesi node.
Yeah, I can attest to that. I thought that your documentation is probably some of the best in the industry, and I'm not just saying that. It was very, very detailed, and I think the thing that really stood out to me was that it really walks you through all of the commands and how to set up a project locally, and it kind of goes through all these steps. And I was running my CLI, and I was running my Docker image, and everything just worked. And like that, I know that should just be the like industry standard, but it's not. Things change so fast, right, in this industry, so it is kind of hard to keep up. But I thought you all have done a great job. So if you get done with this video, someone watching and want to try it out, I recommend it. It only takes about 5 minutes to kind of get started. But so when you're saying like you can now do this, like you all have come a long way in terms of developer experience. What type of applications do you recommend people, and do you see people building? So in my head, when I think of Linux, I'm thinking of, oh, I'm going to go write a web application server, like a backend that talks to the internet. But in reality, we're talking about actual on-chain primitives as well. And so what are I would say, limitations of what you can do, and what do you kind of recommend or see people building here? So like, for instance, can you make an arbitrary HTTP request to the internet, or is it more encapsulated into like a traditional blockchain VM where you can only do like on-chain transactions and stuff like that?
This is very important, actually. You touched a very, very, very delicate topic, because it's something that we always have to explain to people. It's really hard to grasp when you say, okay, I have a Linux environment, so I can do anything. Well, to develop this deterministic environment, we have to impose some restrictions to the environment, right? So the clock of the machine is not currently running all the time. It only runs when the instructions runs. At the same time, the Cartesi machine does not have connection with outside world, with outside internet. Otherwise, you cannot replicate at any time the same computation from the same state, right? So we did have to make it completely protected from this outside world interference. And the only way you should be able to actually insert information there is through our protocol. Of course, that's not necessarily absolutely true. We do have other ways to circumvent this with our integrations, where when you, for example, integrate it with a DA layer, so we have to create this whole door and this whole infrastructure for the inputs arrive through the input layer, right? And still, this kinda enables you to build almost whatever you dream, in the sense that you can use the resources that are prepared for you from Web2. So you can use libraries for databases. You can use libraries for machine learning. You can use any sort of complex computation algorithm that you want or that you need. So we even had people compiling Godot. So you can build games, you can build models, you can do some hard math and hard computation. We do have some crazy good examples of real world use cases, like Bugbuster, which is an application that you actually run and test your code, and people can actually do some bug bounties there, and you can emulate whatever that they proposed as a bug, so you can find and fix. So you can deterministically, you can verifiably show that yes, your program did have that crack open, right? Or we have Rives, which is a whole on-chain console. So many games are being built there. We have DCA Monster, which is a decentralized exchange that does automatically DCA with a very, very small granularity. So you can think of solutions on DeFi, on games, whatever you can picture.
Okay, very cool. That helps a lot. That makes a lot of sense as well. So essentially, if I'm used to writing something like Solidity, I'm already and I'm building smart contracts on whatever EVM compatible network that I'm working on. Let's say I'm writing Solidity, though. I'm already kind of familiar with those constraints. The idea here is that you would have, I would say, similar constraints, but you were able to essentially write in whatever programming language as you would like, but you also can use all these libraries that are available for that
Yeah,
environment. So for instance, I can npm install something and I can build with it, and then I can kind of have all of that as long as we're not interacting with like an external HTTP request.
exactly. So the constraints that are there, they are mostly knowledge constraints. So you have to understand how Web3 works and how asset works, all of that. But your programming constraints are not there as much as they are with Solidity. So it's
Oh, okay,
about
got it.
empowering. So you give the developers a more powerful environment for them to do whatever they want. And the way we build it with RISC-V means that I'm gonna go a little bit technical here, right?
Yeah, go for it.
So as we put a whole operational system right there, we're not just running the programming language as a freestanding way. We're running it in a hosted way. So you're actually running on top of the OS, which gives you things like complex and sophisticated data structure, access to file system, access to memory, which allows you to do some crazier stuff. Now, being a little bit less technical, what this allows, in a sense, is backwards compatibility with everything that was built before, but it also allows for forward compatibility, right? So things that will be built thinking that they should run on Linux, and everything is built thinking it should run on Linux, should run on Cartesi, right? So we are encouraging people now to do some experimentations with Llama, with DeepSeek, and
Wow,
whatever else you can imagine.
that's very cool. Yeah, that makes a lot of sense. So I guess in terms of when you're dealing with certain features and concepts and structures that you're familiar with in a traditional blockchain programming language, we have the idea of essentially transferring tokens and value between accounts and things like that. How does that kind of work? Do you all have your own set of APIs and primitives that exist here that are maybe part of a library or something that you all maintain, or how does that kind of work?
Okay, so for Cartesi rollups specifically, we already prepared all this environment to you. So you're using the Cartesi machine, yes, but there is a whole abstraction node around it and a whole environment collection of smart contracts that will allow you to interface well with this machine, right? So we created this portal assets, for example, that hold your assets right there that you transfer to your application, and then you can essentially interact with them through some dynamics that the Cartesi node provides. So you can, for example, create a specific kind of output that's called a voucher, and this voucher pre-signs a function for you that you can execute later. So you can basically manage the same assets that you deposited into the application. Then you can use these vouchers to interact with the base layer, so you can retract them, withdraw them, right? So you can essentially have something that is equivalent, in a sense, to bridges. So you are essentially bridging all these assets in the tokenomic part to your app.
Okay, cool. That makes a lot of sense. And the last question, as we wrap up this part before we dive into the coprocessor, what would this look like in practice if I wanted to do a token transfer in TypeScript, and I essentially am used to, kind of the API that I'm working with in Solidity? Like, what does that API kind of look like? Just general like overview.
So this API is, for now, we have, I think, smart contracts for native tokens, right? So we have the Ether portal, we have ERC20, 721.
Also, I would call another contract from my TypeScript. Would that be the general idea?
So yes, you can do that, but it's not an immediate action, right? Because as an optimistic rollup, you have to wait for the time of finality of the transaction right there. So what happens is you send these tokens through a transfer method, right? It can be a transfer, it can a deposit, if you rather call it like that. But you perform a transfer for these portals contracts, and inside your application, you use this mechanism that we call, which is a voucher, which is essentially the creation of this calling of this function. So you're basically from your TypeScript saying, I'm going to create this output, which is a voucher, which we created this whole abstraction for. So you create an output from your machine with a specific format that calls that function through the signature that you put in there. So
Okay.
it's called a specific smart contract and a specific signature of a function. So you can do that to call, for example, a withdraw function to remove your assets from there. But you're not limited to just token interactions, right? Because it's this standard format, you can call any function in any smart contract. So
Got it.
through this specific output that we generate, you can interact with whichever smart contract that you would like.
Okay,
So,
got it.
yeah.
So if I was to build something very custom using Cartesi, would I need to probably? So would the different components be? I would have my TypeScript or my other programming language, my code base there, and that would interact with these other contracts that kind of already exist in the wild. Would I need to also write any other smart contracts externally, or not really?
No, not really. Actually, this is all prepared for you. Once you deploy, we have pre-deployed in some blockchains, and you can easily deploy on any other EVM-based blockchain our framework smart contracts, right? Which are used for whichever dApp is deployed there in that chain. And then there are the specific smart contracts for your application that are actually deployed when you are performing the deployment of your node, right? When you finish building your machine, you generate its image, then you get this image, and we already have a web page where you simply put the image hash of your machine, and immediately you deploy your specific applications contracts that are default, are standard. You don't even have to see them, and the magic happens and they interact with your TypeScript with your TypeScript code, right? You can, of course, implement other Solidity smart contracts, and through these mechanisms of vouchers, interact with them or perform any kind of abstraction you want to send a transaction to your smart contract, and then your smart contract sends a transaction to our framework smart contracts, which will interact with your application. So you are allowed and flexible to abstract however you want, but you don't need to if you don't want to.
Very helpful. Okay, cool. So now let's go to the coprocessor, which is kind of the newer product that you all are building. If someone asks you to define like what a coprocessor is, let's just start with that. What is to you a definition of a coprocessor? I have my own definition, but I want to hear yours.
Yeah, that's very hard because sometimes these concepts go very blurry, right?
Yes,
But
exactly.
I think for me specifically is an assistant processor. Like the idea of co-processing something is being an assistant that serves another application's logic through this specific environment or this specific requirements that you have for your application. I think summing up in the most summarized way, it would be that.
Cool. That makes a lot of sense. And with that in mind, tell me about the Cartesi coprocessor and what the idea behind building it was and where it fits in with everything else.
So I think there are many reasons for us to want to build this coprocessor. But the most important is the easiness that it would be to integrate with existing solutions, or to just use the computation when you need to. You don't always need to have that node running as a specific app chain on top of another blockchain. You can simply delegate the parts of your application that you actually need to have this more powerful logic,
right,
to the coprocessor. I don't think, for example, if we're doing marketplace that has some algorithm for suggestions, you always need to have the whole logic of the marketplace in your TypeScript code. Sometimes you can already have this order book logic on your Solidity smart contracts, and then go to your coprocessor just to get the specific data that you need to, I don't know, perform a recommendation algorithm, for example.
Makes sense. So, in terms of what this might look like from a use case perspective and a developer experience or developer, I would say maybe developer experience perspective. If I'm essentially building on Cartesi, or if I'm building on some other smart contract blockchain, am I able to use this coprocessor, or is it strictly limited to within the Cartesi VM?
So the Cartesi coprocessor is not engaged through the Cartesi VM. It's engaged through the blockchain that you need. So, for example,
so you can use it pretty much anywhere.
Yeah. So you can, if you're using Ethereum, for example, as long as you have a interaction with the eigenlayer interface, you would be able to activate this coprocessor, right? So essentially what you're doing is running whatever code you need on your smart contract, calling this coprocessor interface that will engage the solver and the operator in the eigenlayer ecosystem for you to run your whole computation right there.
Makes sense. So you're essentially emitting an event off of your contract and picking it up, and then it gets sent back to your contract from the coprocessor?
Exactly.
Okay, cool. So if you want to write your own custom logic in the coprocessor, how do you do that? Or is it, yeah. So if I wanted to, say, call this coprocessor and I wanted to multiply like 1,000,000 times 1,000,000 or something, or I wanted to call a service and do some calculations and aggregate some data, like what type of things can you do, I guess, there?
You can do pretty much anything you desire. So you simply call it through this issue task, right? Interface function, call coprocessor function, which is pretty simple, pretty easy. I can show a demo. I don't know if
that would be amazing. If you have that, yeah.
Let me just pick it up here and stream, right?
Cool.
Your screen, window, entire screen, and that's my window right here.
Okay, cool. I see it. Can I add it to the stage?
Yeah.
There we go. I see. You might want to zoom in a tiny bit.
Okay, so let's go. I think that's better, probably.
That's better. Perfect.
That's too much.
Yeah, either way, I think it's fine.
Okay, so here we have a smart contract that inherits from this coprocessor adapter, right? And there's basically two functions that you have to really consider. The call coprocessor here, which essentially gets whatever input that you want to your coprocessor. It has to be a hex encoded input. So in here, for example, I'm sending directly the input I get, but I can pass whatever parameters I want here, do some pre-checking in my Solidity logic, and then only call the coprocessor with whatever I want, right? And then I will call this function, which will engage my coprocessor. And in here, I will be able to hand the output. Handle notice. Notice is one of the kind of outputs that we use, right? So I receive, I do whatever check I need with this output, and then I do whatever I want with it. For this application, I'm just storing a value in this survive variable here, because I wanted to show that you can actually hold state in this application, right? Then, of course, we have our application logic, our Python program here. We do have some auxiliary functions here, like string to hex and hex to string, and emit notice, which is the creation of the output. But what this project really does is it gets an input, it formats the input that comes in a JSON format, and then it calls a model that I have implemented here, which is the Titanic survivor model. This is a very, very common data set used for machine learning studies, right? Which is if a passenger of the Titanic would survive or not. And the way it actually happens is just through this very, very simple and straightforward interface. So once it hits here, it processes my Python code. This is very simple, very regular Python code. I get the payload, transform it into string, transform it into a JSON. Then I read the data from the JSON, and I call my model, which is basically a score.
Oh, very cool.
So it's the simplest machine learning model you can
Well, it's
think.
a perfect example because you can just read through this and kind of get an idea how it all works, and then you can kind of start imagining what else you might be able to do, you know?
Yeah, exactly. That was the whole idea. So just to show it to you, I do have a video here because it's always better to showcase with a video, right?
Yeah.
But of how it would look like, the application itself. So I did a very simple front end for it. I just have to connect my wallet. As you can see, I have my services running locally here with the solver and the operator, which are basically the components that take the transaction, delegates it to the operator to process my coprocessor logic. So I'm sending the information of a male of age 65 that embarked from Queenstown. And you can see that this information is directly sent to my solver, which figures out what is the machine hash. So what is the coprocessor machine that it has to use, and send this input to it. Mm-hmm. So this input, as you can see, basically has the same information as the information provided. And once submitted, you can see in the operator logic, the operator contains all the logs of the Cartesi application. So you can even see in the application, wherever I put print, it actually prints right there. So it's very easy to debug and follow up what's happening with your solution as well, right? So once you do that, you can check status, and you can see that this person would probably get drowned in the Titanic. But if you watch Titanic movie, once again, you know they prioritize saving the females and the young people. So in the same way, we can check the same data coming from the operator and going through the solver. But I think the important part of understanding what's happening there is that this logic wouldn't be possible to implement in Solidity, right?
Absolutely, yeah.
This would be so complex to actually be able to pull off, which, well, I think you would basically have to reinvent the wheel.
Right, yeah. I mean, imagine doing that logic and Solidity. I mean, just not even counting. I don't know if you were interacting with another service or not, but let's just say you were not. Yeah, just doing some crazy calculations like that within Solidity would just be insane.
Yeah. This would be completely crazy. So I don't know. I'm pretty happy where we landed so far.
Yeah, the API looks really simple. I guess the question is, so I write my Python or whatever, my TypeScript, which is going to, yeah, what languages can you write for your coprocessor?
So basically anything that runs on Linux would run there. It's a whole Linux environment that you have booted up. You can even program it in assembly or
can you call like OpenAPI and other APIs like that, or is it limited to whatever you have running also locally?
It's limited to, for now, it's limited to whatever you have running locally.
But you can do like local imprints and stuff like that if you wanted to run like a local LLM.
You can run a local LLM. For now, it's not the most performant thing, but we did have some crazy studies in the last hackathon experiment week that we had, where this amazing developer that we have is like one of the best developers I know, probably Eduardo. He actually managed to use the machine IO to communicate with the host machine. So you're not necessarily having to run the LLM on this emulated environment, because you can delegate the matrix multiplications to the hosted machine. So he accelerated like crazy the performance of the LLM. So it started to be a little more viable. It still has a long way to go, a real long way to go, but it's looking very nice so far to be able to actually run verifiable models on chain.
Very cool. So I guess one thing that comes to mind, it's like when I was learning Solidity, I'm now not just dealing with strings, because like when you deal with like a string, and especially back when we were just on L1, you had to really think about gas, and you had to do a lot of gas optimizations and all this stuff. But if you're using something like this, and let's say you're building on base, and you don't want to deal with all of this stuff, theoretically you could essentially just have, other than like token transfers and stuff, you could almost have like all of your computation done within the coprocessor if you just want to write TypeScript or whatever, and you want to build like traditional, like crazy, interesting web applications, like social applications, for example, right? Where you want to do, dealing with like user relationships and like information metadata, like large amounts of metadata and stuff like that. You might do something like that within Cartesi, and then all you're doing is using the smart contract as like an entry point for the API, and then it kind of uses the coprocessor for most of the logic. Like that might be a really fun use case.
No, yeah, exactly. I mean, one of the most amazing use cases I've heard someone come up with so far. It's one of the Cartesi co-founders, Felipe. He always mentions this social network where you can actually choose and pay for the recommendation algorithm that you're used within that same social network, right? So you could theoretically have multiple coprocessors, each one with the implementation of a specific recommendation algorithm that you have, and then your feed would be created based on that. But the whole computation would be happening outside, which is insane.
That's crazy. No, it makes a lot of sense though. Yeah, it kind of just opens up really what you can kind of do with the, I would say, same skill set that a lot of developers have coming into Web3 that might not be expert Solidity or Solana developer. Well, by the way, does this support anything outside of the EVM at the moment?
Not for now, but it's always a possibility.
Got it. So EVM, but if you're building on Base or if you're building on Arbitrum or Optimism, you can use this, right?
Yeah.
Cool. Yeah, I mean, the thing that also kind of stands out to me was what I was just touching on. It's like if you're coming from a traditional background and you want to start building on-chain applications, you could kind of like consider this as also a tool to use to not have to worry about diving deep into some of the more complex stuff in terms of like writing Solidity. But honestly, dealing with like really crazy data structures and Solidity for a lot of stuff, you really have to go out of your way to make it work. And then being able to just maybe offload a lot of that more complex computation just seems like a better workflow. I'm wondering if we're going to start seeing these types of tools be kind of incorporated more into, applications in the future as they become more widely available.
Yeah, that's the thing. Creating Cartesi, I think the whole idea was never to replace Solidity or to just allow you to do what you're more comfortable with. Because if you can implement it simply on Solidity, maybe it's easier to just go that way, right?
Absolutely.
But if you really need to be unlocked to do something else, then you have found the perfect place to use Cartesi, right? I always like to make that analogy of in the space race, people inventing this whole crazy pen that would be able to write outer space, and you would be able to use to press ink against the paper without gravity, which is kind of insane. But otherwise, you could just have gone much simpler and use the pencil, and it would also work, right, in on space. I think that's a good analogy, but of course it's much more complex because we didn't just use the pencil in this case, but it's just a better way to understand, because we still had to create and use all that rocket science to build everything that goes around it. But totally. In a sense, we're allowing people to use the pencil, I guess.
Very cool. Okay, cool. This has been really great. I think I learned a lot, and I really got all of the answers that I wanted, I think, through this discussion. But before we wrap it up, do you have any last things that you want to touch on or mention before we kind of dive into maybe some resources that developers can kind of go to? And also maybe we'll talk about the experiment week real quick that we have coming up next week.
Yeah, of course. So I think that's the most important thing that I would like to talk about, the experiment week that's coming on. It's pretty amazing. It's almost a tradition at this point that we have in Cartesi to do these experiment weeks. It's a great opportunity to see the brains, how the brains of the people who are creating the solution work behind it, right? And lots of cool things come out of it. Solutions, complete apps, or even just tooling that goes around it that we were never able to prioritize in the day-to-day, but it's something that we always felt we needed. So we can take this week to focus on creating this tool, this solution that sometimes becomes something so huge and so useful. It's always great to see. And this time we're doing it with the Coprocessor. So it's the first time we're actually like experimenting a new product in the experiment week.
Yeah, and the documentation for the coprocessor just really kind of is coming out because it hasn't really been available up until now. So if you're watching or you're participating in this event, you're going to be kind of getting a first look, and you're going to be one of the first developers being able to build here. And it's really cool because it's literally an experiment where you can literally experiment and build something fun and cool and talk about it and make money to do that. So I think if you're a developer looking to expand your skill set, you want to kind of be on the bleeding edge. This is a perfect opportunity to consider doing that, because you could probably build something cool if you're a good developer already, probably in like a day, right? Or something like that. So.
And I can tell you, it's one of the most fun ways to have a hackathon, because you don't have that feeling of being competing with everyone, because it's a little different. Everyone's helping each other all the time. So last time I really needed some help with account abstraction, and someone came to aid me right there. It's really good to see that as well. Sometimes someone creates a feature on Cartesi. So Danilo last time created this wallet abstraction feature that we can use with the CLI. So good. And immediately in the experiment week, he used it, and he made such a cool project with it. So it's always nice to see what was the inspiration for the people that are creating those solutions.
Yeah, totally. So I guess, excuse me, for developers that want to get started with the experiment week, what does the process look like to kind of get started?
Yeah, so we created this docs in our experimental docs page, which is docs.mugen.builders. So Mugen is Mugen. Yeah, and there you can see the Cartesi coprocessor dev journey. So it guides you to the whole way, like how to install, how to build your solution, how to deploy your solution. So you can deploy on testnet, you can deploy on mainnet, and we provide you with a CLI. We try to make it as best as possible, as similar as possible to our current rollups dev journey, so people are more familiar with it already. So you spin up your own DevNet environment and you start deploying your dApps in there. This is all automated, so you don't even have to worry about. You just have to code your application and start playing with it.
So where can they sign up to be eligible for the prizes, I guess, as well?
Oh yeah, that's very important. That's in our DevFolio page. I don't remember the link by heart, but I highly suggest that anyone who wants to follow can follow any of our socials, right? Cartesi and Eigen, and we've been talking about it a lot there. And Discord as well, because the community is buzzing with it.
Cool. So if you go to devfolio.co and you click on the hackathons that are happening right now, you'll see the Cartesi hackathon. And also if you go to the Cartesi Twitter, you will see a lot of like links and resources talking about this event as well, or the experiment week. Cool. All right. This has been great. Thank you again for your time. I learned a lot, and I know everyone's busy these days, so I value your time. And if you're watching, thanks for checking this out. If you missed the beginning of this, we're going to, it's already now up on our YouTube, and we're going to go add links for all the things we talked about, the documentation, the experiment week sign up, and the main Cartesi documentation, as well as the coprocessor. So thanks for your time today. It was nice to meet you, and I hope you have a good rest of your day.
Thank you so much. It was amazing being here. Thank you for the opportunity. And yes, can't wait.